Compressibility characteristic of municipal solid waste in Meethotamulla wastefield site. I am G.D.W.N.Galhena from National Building Research Organization, and co-authors are Professor S. Kulathilaka and Professor P.Nawagamuwa from University of Moratuwa. These are the content of my presentation. Introduction. Municipal solid waste describes as the discarded materials, substances, or objects which originates from domestic, business, and industrial sources, including household waste, which are typically disposed in municipal type landfills. In Sri Lanka, open dumping is the currently adopted method due to low cost and less processing involved. Recently, municipal solid waste management became a growing concern in Sri Lanka with the catastrophic landfill failure occurred at Meethotamulla. Accordingly, it has been decided that on-site closure and rehabilitation is the most viable economical solution for the Meethotamulla abandoned site. In such rehabilitation work, geotechnical risks such as stability and settlement issues in landfill are need to be addressed. Determination of stiffness characteristic of solid waste is useful for assessing the deformation of waste dump and the effect on structures built on landfill with post-closure plan. However, relevant studies for landfill in Sri Lanka are very limited. Methodology. By considering the facts identified through literature, laboratory test program was conducted to study the consolidation behavior of MSW. Consolidation tests for MSW are performed using the raw cell. As the size of raw cell sample is larger than oedometer sample, it can accommodate a more representative sample. Based on experimental data, compressibility characteristic of municipal solid waste were determined. Accordingly, possibility of improving the MSW characteristic by preloading was assessed. Experimental program. For this study, samples were obtained from waste dump site at Meethotamulla. Samples representing 2 degradation levels were collected. These samples are more than 20 years old and primary biodegradation is completed. One sample is obtained from the bottom of the waste dump and second sample is from the middle part of the waste dump. In order to identify the composition of waste sample, waste classification framework proposed by Dixon and Langer is used in the study based on the relevancy to nature of municipal solid waste in Sri Lanka. In both locations, identifiable paper, cardboard, or any other organic materials were not encountered. Hence, it can be concluded that all degradable components were fully degraded. As shown in graph, location 1 contains more degraded materials and location 2 contains more polythene and textile. For experiment works, raw cell with diameter of 151.2 mm was used. At the latter part of experimental program, few defects were encountered in large raw cell. Therefore, raw cell with diameter of 75.7 mm was used for one test series. In sample preparation, fragments greater than 25 mm in specimen that were too large to fit inside the cell were cut into small pieces and discarded where it is not possible to reduce the size of component. For the experimental works, recompacted samples were used. Samples were prepared inside the raw cell into similar bulk density which is obtained from the field test. The two tests were conducted from each sample. One is under saturated condition and other sample under unsaturated condition. In the preparation of saturated sample, attempts were made to achieve the fully saturation level by adding water to sample. These are the loading cycles followed for the experimental works. Further, basic properties such as bulk unit weight, specific gravity, and moisture content were determined. These are the results obtained for each sample. Based on the obtained data from test, settlement bus log time plots were developed for all loading increments and reloading increments. This graph shows the settlement plot for sample 1 for loading and reloading stage. These are for the sample 2. As shown in this graph, the settlement plots do not show a reduction in gradient with time as seen with inorganic clays. The plot of similar gradient as seen in PT clay clearly indicates that MSW sample have high secondary consolidation settlement. In the reloading stage, settlements are much smaller as seen by change of the vertical scale of plot. Then E versus log sigma curves were developed and it shows similar pattern as the E versus log sigma curves for intact or engineering soil. Variation of volume compressibility for reloading and loading stages are shown in this graph. Continuous line represent the loading stages and dotted lines are for reloading stages. As shown in this graph, MV values of all samples decrease as the effective stress increases. MV values of unsaturated samples are less than the value of saturated samples. Also, variation of secondary consolidation with respect to each stress levels were plotted. The C alpha values of unsaturated and saturated samples were of the same order. The CV alpha in reloading increments were much smaller compared to that of loading increment. Hence, it confirms that the secondary consolidation characteristic of municipal solid waste can be significantly improved by preloading. Even though MSW has high secondary consolidation, the magnitude of the secondary consolidation coefficients are lower than that of PT clay. Further, secondary consolidation index with respect to OCR is plotted, and it can be seen that reduction of C alpha achieved is larger with the larger OCR. Practically, OCR value of the range of 1.2 can be achieved in a field preloading process. The results indicates that significant reduction of C alpha can be achieved with preloading of that extent. Next important parameter is the variation of coefficient of consolidation. For this, we have considered 4 curve fitting methods. As settlement versus log time plots were for waste samples has not followed the typical S shape, transition from primary consolidation to secondary consolidation couldn't identify clearly. Therefore, log time method was omitted. This is the variation of CV for different methods. The CV values obtained by all methods are showing the same trend on increasing stress level. Apart from the initial increment 0 to 25 kPa, the coefficient of consolidation values were of the same order in other higher stress levels. CV values of sample 1 are higher than the respective value of sample 2. As sample 1 contains all the degraded waste, this result proves that degradation level has significant impact on the rate of consolidation. Conclusion. Volume compressibility values of all samples tend to decrease as the effective stress increase, and MB values for saturated samples shows higher compressibility values at each stress levels. The value of CC and CR for the MSW specimens under saturated condition are higher than under the unsaturated condition. There was a considerable reduction of coefficient of secondary compression during reloading stage compared to loading stage. These results indicate that the compressibility characteristic of municipal solid waste can be improved by preloading. In recent times, the preloading was very effectively used in construction of roads through sites underlain by PT clay. Hence, in the rehabilitation of municipal solid waste landfill and converting them to useful lands, preloading process can be adapted to ensure that the settlements of these improved grounds are well within the acceptable limits during the service stage. Due to high coefficient of consolidation, technologies such as PVD may not be necessary to accelerate the consolidation. These are the references, and thank you for listening.